We'll continue our lesson with the other chemical bonding, that is covalent bonding. After you learn about ionic bond that become ions, positive and negatively charged ions from metal and non-metal, and then right now you will learn about covalent bonding between non-metal and non-metal. The outcome, the same as before, to draw the diagram or dot cross. They will reach noble gas configuration to be stable. Helium, the first noble gas, and then neon, and then argon, krypton, xenon, and radon. Helium number 2, the configuration 2, neon 10, the configuration 28, argon 288, krypton, xenon, and radon. Helium duplet, and the other is octet with 8 valence electron. Once again, we review chemical bonding. There are 2 types. First, interatomic bond, and the second is intermolecular forces. Interatomic bond. Right now is covalent. So this one. For intermolecular forces, there are 3 types: van der Waals, permanent dipole-dipole, and hydrogen bonding. We will skip this. For covalent bond, consists of 2 or more non-metals. They are able to bond together by sharing their valence electron. Here notice for covalent there is overlap here between 2 atoms because they share their electron together. Construct the diagram of CO2 processes from C and O. C number 6. So the configuration is 2 and 4. O number 8. The configuration is 2, 6. So there are 2 shells of carbon. Then we want to draw the electron. The first shell 2 electron, the second shell 4, then for oxygen, first shell 2, second shell 6. Then here carbon with 4 single electron, but oxygen only 2 single electron. So when they want to join together, one carbon atom needs 2 oxygen atoms because there are 4 electrons that will be shared together with oxygen. So we need another oxygen here, 2 and 6, like this, the same. Then after that this single join with this single join with this, and this one join with the other atom, the single one, this join with this. So you have one carbon, two oxygen with two shells each, and then they join one carbon atom join with one oxygen atom with two pairs of electrons. So here you have two carbon electrons and two oxygen electrons joined together, and then the same way here, two carbon electrons, two oxygen electrons joined together, here overlap, and then oxygen, there are two lone pairs here. There are two lone pairs here. Here two inside the inner shell, two, the outer, two lone pairs. So between C and O exists double bond. One line indicating of two pairs of electron. Here you have example of water molecule, H2O, one hydrogen, one oxygen joined with two hydrogen. This is the oxygen. Carbon dioxide, CO2, and then nitrogen dioxide, NO2, this is CO2, and then ammonia, NH3, oxygen molecule, O2. You have NO2. Why NO2 has one single? So this is a radical. That's very aggressive molecule. N is number 7. So the configuration is 2 and 5. So firstly you draw the symbol of nitrogen with 5. 1, 2, 3, 4, 5, and there are two oxygen. Here we want to draw the NO2, so there are two oxygen. Oxygen is number 8, configuration is 2 and 6. So for oxygen you have 6. I just draw the electron without shell. Here 6 electrons, like this. Single with single, so become double. And then these two electrons will given to oxygen, then become dative. So this dative by arrow. Then this oxygen not use the electrons at all, but only use the nitrogen electron, and then remain this one electron here, like this. Like this. For H2O, O with 6, 2 single, join with H to H, because H is number 1, so the configuration is only 1. For HCl, H only 1, join with Cl 7. I only draw the electron without shell. Yeah, the other example is S8 here, and then you have once again hydrogen, oxygen, nitrogen, and 2Cl2, chlorine, nitrogen oxide or monoxide, NO, water, nitrogen dioxide, and carbon dioxide. So here we separate the difference between this one and this one. For the first row, the type of atom the same, HH, OO, NN, CL. So we say that the particle is element molecule. Molecule is a combination of atoms. Your combination of two the same atom, then we say as element molecule. But when the component different, such as NO, H2O, NO2, CO2, then we say that the particle is compound molecule. This is some example of the dot cross diagram. Oxygen O2, O with 6. So this one join together to be double. So we can draw in line like this, double bond. For HCl, for H, like this, only one pair, single bond. For methane is CH4, this one. C is number 6. So the configuration is 2 and 4. So the valence electron is 4. This. So there are 4 single electrons ready to join to attach to hydrogen, but hydrogen only has 1. So one carbon atom will need 4 hydrogen atoms. So the H is times 4. We need 4. 1, 2, 3, 4. So the molecular formula of methane is CH4. Here we have C3H8. So first, you already learned about hydrocarbon. Carbon in 4 valence electron. We join first the carbon atoms together, and then with other C atom. So just need this to be joined, to be single, and this one with other C. So the rest is for this C, there are 3 that will join with hydrogen. Hydrogen only has 1. This with 1 hydrogen. So this C with 3. So we can draw like this. For this, we'll need 2 like this. The rest 3, so we can draw like this. Here we have example of C3H8 and pH3, CS2, BF3, and SCl2. For CH3, 1C held 4 valence electron. This one is carbon. Join with 1 carbon, so we can draw like this, 1 pair, single, and then the rest of carbon electrons, there are 3, join with 3H here. For the second carbon, the rest is 2 electrons and need 2 hydrogen, and the last carbon with 3 pairs from carbon and hydrogen. This is for pH3, pH number 15, 2, 8, and 5, so the valence electron is 5. So P with 5 electrons, but H only has 1, so 1P will need 3H. In the same way, CS2 the same as CO2. You can try by yourself. Here, the same as H2S. Because although Cl has 7 valence electron, but that available for the bonding is only 1. That's the single one. So what is the geometrical structure or the shape? The shape for CH4 is tetrahedral like this. This is for CH4. So for C3H8, this tetrahedral will repeat twice like this. For water molecule, dot cross diagram, water H2O, O is number 6, so O with 6, with 2H. The number of electron is 4 pairs around the central atom oxygen. Then 4 pairs of electron will be the same as CH4. That's tetrahedral for CH4. But here for H2O only 2 bond pairs. The other, this one, is lone pair without atom, lone pairs. So in here, for oxygen, H and then H. For this is empty. So the shape will be V shape or bend. Yeah, here. Here, CH4. This is the tetrahedral. For water, these two parts of the structure empty without atom. So the shape will be V, not tetrahedral. If like this, then tetrahedral. So the same for CH4 or CCl4 will be the same. The difference only in this. If this is Cl, then around Cl will follow octet rule. For hydrogen, duplet. Around hydrogen only 2. Around Cl, there are 8 electrons in the outer shell. Okay, once again, this is for water. This is the band shape for tetrahedral, but empty to place this here. So we say as band of V shape. The angle is measured as 104 and 104.5 degree. Another example is beryllium chloride, BeCl2. BeCl2, Be is number 4. Be is number 4. So the configuration is 2 and then 2. So outer shell electron only 2. So here belong to Be, to Be. This one belong to Cl with 7. Each Cl has 7 electrons. So like this, with one pair of bond pair between Be and Cl. So the angle is 180 degrees. This is the BeCl2. So the general formula is AX2. 1 Be A, 2 Cl X2. The shape is linear geometry like this, with the angle is 180 degrees. Another example for NH3, Y like this, and the shape is pyramidal, trigonal, or trigonal pyramidal, because one pair is empty. N is number 7, so the configuration is 2 and 5. The dot cross of nitrogen 5 will join with 3 hydrogen, because hydrogen only provides only 1 electron. So 1 nitrogen atom will need 3 hydrogen atoms. So there are 3 bond pairs between N and H and 1 lone pair. So this one is empty, but the total number of electron is 4. So 4, the original shape is tetrahedral, but this part is empty, so it become like this. This one is the empty one, only lone pair, one pair of electrons, no atom here. So the shape is pyramidal, trigonal pyramidal. So NH3 has 1 lone pair and 3 bond pairs. For H2O, the lone pairs is 2. The bond angle for NH3 is 107 degrees, but for water only 104.5. Why? Because the lone pair, there are 2 that suppress the bond pair, that the lone pair can repel each other stronger than the bond pair. So this from tetrahedral is 109.5 degrees. For NH3, the lone pair only one will repel this to be smaller angle, 107 for NH3, but for H2O there are 2 lone pair, so this will repel stronger, so the angle become smaller. Here you have some molecules. CO2 linear because there are 2 bond pairs. They will repel each other between the bond pair. Then the shape will be linear. That's the farthest that possible between the bond pair. For SO2 Y band, S is number 6, oxygen 6 as well. The number of valence electron, S is 16, so 2, 8 and 6. O is 8, 2 and 6, so the same, in the same group S and O. 6 valence electrons, so how to draw S and O2? S with 6, 2 lone pair, 2 single electron. The same with oxygen, 2 lone pairs, 2 single. These 2 single will join to become double. Double we count as 1 bond pair, and then the rest 2 lone pair, 2 single. But here there is no single in S because the 2 single electrons already used to this oxygen. So the rest is 2 lone pair. So to become octet, then the oxygen, the second oxygen, not use the electron. The bond pair only comes from the sulfur. Here, this one, given to oxygen. And this arrow represent 1 pair of coordinative bond. Then there is 1 lone pair left for sulfur. So here around central atom S there are 3 pairs, 3 bonds, 1, 2 and 3, but the atoms that attach or bind with sulfur only 2. So for 3 the original is trigonal planar, like this. This is S, O, O. Here is empty, so the result is bent. You can try for a BCl3, boron number 5, so 2, 3. So for boron there are 3 single electron, no lone pair. Join with 3 Cl group 7, 7 valence electrons. So one boron will need 3 Cl atoms. So right now in the molecule there are 3 bond pairs, no lone pair. They repel each other. Then the farthest distance is like this. It's trigonal planar. You can try for BRF3. They both are halogen atoms. So 7 valence electrons. You can try by yourself. You have a lot here. SF6 you can try. S group 6 valence electron. F group 7. So there are 7. If there are 6 bond pairs, then the shape is octahedral. In horizontal, this part, and 1 atom at the top, 1 atom at the bottom, like this. If you make line here, then 1, and then 2 here, and then 3, and then the 4th is at the back. In the same way, to the bottom, there are 4. 1, 2, 3, 4 at the back. So you have 4 here for a triangle times 2, so become 8. That's octa. 8 is octa. For ClF5 you can try for xenon tetrafluoride. Xenon actually is noble gas, and join with F, noble gas with 8 valence electron, join with 4F, F is 7. So here what will be used to join with xenon is this single, but in xenon there is no single, so this will behave as single with 4, so this will behave as single like this. So there are 2 lone pairs. For XeF4 is the 2 lone pairs. Because the number is 6, then we'll follow this. But 2 places are empty. So the result is square planar, this one. Still you have here some other example. PCl5, you can draw the dot cross by yourself. SF4, ClF3, and I3 minus. Here, the lone pair repulsion is bigger than the lone pair bond pair repulsion. Bigger than bond pair repulsion. So for PCl5 like this, one at the top, this is central, one at the bottom, and then the 3 horizontal in here form triangle. 1, 2, 3 like this. That's for PCL5. Here, in case of SF4, the basic pattern or the basic shape the same as PCL5, but there is one lone pair of electrons in here. The lone pair has repulsion bigger than bond pair. So here the angle between this is 90 degrees between the horizontal atom here, because it's triangle, then the angle is 120 degrees. One circle 360, so divided by 2, so 120. So here there is bigger space, then the lone pair will take the position in the triangle here. So one of the place of atom here will be empty, just only lone pair. So right now this is the shape seesaw, like this. So review once again. This is for BeCl2. This is for BF3 with 3 bond pairs, trigonal planar. This is linear for BeCl2. But when there are 3 like this, 3 bond pairs, but one place is empty, only occupied by lone pair, then the shape will be bent or V shape. When you have 4 around the central atom, then the shape is tetrahedral. But when one of these is empty, then the shape is trigonal, pyramidal. When 2 empty, then you have bends, like that. Yeah, you can see here. This is for CH4, for example. This is for PCl5. This is for SF6. Trigonal corner, bend, tetrahedral, pyramidal, trigonal, pyramidal, trigonal, or trigonal, pyramidal, H2O bends or V shape, trigonal B pyramidal is for PCl5 or BF5, the same, like this. One at the top, one at the bottom, 2 in horizontal. So you have here, you have pyramid. There are 2 pyramids, and the base is trigonal. So you have pyramidal, trigonal, bipyramidal. Because you have 2 pyramids. Seesaw, like this. This is empty. This is seesaw. The shape ClF3, linear XeF2. For XeF4 is square planar. Like this. is empty. This is empty for XEF for XEF2, XE with 8, but only 2 will join with F. Then the rest is 3 with 2 bond pairs, so totally 5, the same as PCl5. The lone pair will take the bigger space here in this position in the triangle. So 3 lone pair will take this position. So with 2 F atom in this position, this one. So you have this. So this one is linear 180. This one. Yeah, the last you can exercise yourself. Answer question 2 and question 3, page 52 and 53. You can ask if you have any question through WhatsApp. That's all for geometrical structure or shape of molecule and covalent bond.